In this video, we want to continue on with our examples of solving first-order separable differential equations. So we might recall that this equation, x prime is equal to 2xt plus 2t minus x minus 1 is separable. In fact, we can rewrite this as dx dt is equal to 2t minus 1 times x plus 1. And once we are done with that, we can rewrite this as dx over x plus 1 is equal to 2t minus 1 dt. And we have successfully separated our variables. Then recall that to solve this equation, we integrate both sides. The left-hand side will be integrated with respect to x. And the right-hand side will be integrated with respect to t. So the integral of the left-hand side is the natural log of the absolute value of x plus 1 plus some constant c, but again, remember we're just going to combine the plus c's on both sides and make that into a new constant c. So we'll just leave that off for now. So the right-hand side, we are integrating with respect to t. Well, 2t minus 1, the integral of that is t squared minus t. And then again, we're combining our constants over to the right. And this is our solution. All right. That is it for this particular problem. We'll move on to two more examples here in this video. Okay, so here we again want to separate our variables. We have 1 plus t dx is equal to x squared dt. Okay, so this becomes dx over x squared is equal to dt over 1 plus t. We want to integrate both sides. So dx x squared is equal to integral of dt 1 plus t. So the integral of x squared, 1 over x squared, remember we can rewrite this as the integral of x to the negative 2 dx. What is that? Well, we add 1 to the exponent and then divide by that value. So we get negative x to the negative first plus c, or in other words, negative 1 over x plus some constant c. We also want to integrate dt over 1 plus t. Here we need to make the u substitution 1 plus t. So we can rewrite that as the integral of du over u, which is the absolute value of u plus some constant c, which is equal to the ln, the natural log of the absolute value of u, plus c, which is equal to the natural log of the absolute value of 1 plus t, and then of course plus some constant c out at the end. Combine all of this, and we get on the left-hand side negative 1 over x. And this is equal to the right-hand side, which is ln of the absolute value of 1 plus t, and then plus some constant c. Again, we combined our constant c over on the right. Okay, and that's the end of that example. We got one more example in this video. And that is the initial value problem. Again, we want to start with separating our variables. So we get dx over x cubed is equal to t dt, right? We multiply the dt on both sides here. T dt over 1 plus t squared. All right. Then we take the integral of both sides. The integral of the left-hand side, the integral of x to the negative third power is negative 1 over 2x squared plus some constant c, but we're going to ignore that because we're just going to move that over to the right in the end here. And this is equal to, all right, now we need to integrate the right-hand side. Okay, let's do that. To do that, we need to take u is equal to 1 plus t squared. So du is equal to 2t dt, or in other words, du over 2 is equal to t dt. So the integral of t dt over root 1 plus t squared is equal to 1/2 the integral of du over the square root of u, which is 1/2 the integral of u to the negative 1/2 du. All right, to integrate that, we add 1 to the exponent, so we get a positive 1/2. Then we divide by 1/2. Well, division by 1/2 is the same as multiplying by 2. So this just becomes u to the positive 1/2 plus some constant c. Recall that u was 1 plus t squared, so this is really equal to the square root of 1 plus t squared plus some constant c. So that's what's on our right-hand side up here. So we get that. Okay, now I'm going to erase this page and rewrite this statement here. So we had negative 1 over 2x squared is equal to the square root of 1 plus t squared plus some constant c. And now that we have found our general solution to this differential equation, we need to solve the initial value problem. We have that x of 0 is equal to 1. That means x is 1, t is 0 here. So we get negative 1 over 2 times 1 squared is equal to the square root of 1 plus 0 squared plus c. And we solve for c. So we get negative 1/2 is equal to 1 plus c. So c here is negative 3/2. If we combine all of that, that tells us that our solution should be negative 1 over 2x squared is equal to the square root of 1 plus t squared minus 3/2, since c was negative 3/2. And that is our solution to the initial value problem given here. And that also concludes our video on separable differential equations.